Beginning of our review begins with radical simplification or expressing it. So what are some factors of 54? 6 and 9. We don't really have to go any further because 10.1 was all about finding that perfect square that's on the inside. Does 6 break down to anything that has a perfect square in it? No, but 9 does, right? What does 9 go to? 3 square root of 6, and we can leave it like that. If not, you guys can continue a whole factor tree. Remember, 10.1 was finding those perfect squares. On the second one, you guys have a couple options. Your first option is to multiply them together and then try to find what comes out of the radical. Or we can try to simplify the radicals and then multiply them together. Which one do you guys want to do? We'll go with the first option, multiply them together. So we multiply our coefficients. 2 times 4 is? 8. Yep. And then we have 6 times 20, which is 120. What are factors of 120? Yeah, we can do that. 2 and 60. Factors of 60? 2 and 30. Factors of 30? I actually like this trend. 2 and 15. Factors of 15? 3 and 5. Nice job, guys. So things that have buddies are the 2. They come out. So 2 times 8. What doesn't have a buddy stays locked up. So that's the 2, the 3, and the 5. We multiply those all back together. Well, we'll do 3 times 5 is 15. 15 times 2 is 30. So it's getting a B. Bless you. What's 2 times 8? 16 square root of 30. So the next one up, we can do the same thing. Multiply our coefficients. If you cannot see the coefficient, we know it's 1. So 1 times 13 is 13. 3 times 5 is 15. Factors of 15. Do either of them have buddies? No. Nope. So our answer is 3 square root of 15. If you get one that is what the question was to begin with, like on your quiz, I think you guys had square root of 3, whatever it was a prime number, and then nothing had a buddy. It wasn't a prime number. Nothing had a buddy. Make sure that you guys write it out again. Don't just leave nothing there. Like, tell me that was your answer, that it went back to the original. Because if you left it blank, I didn't give you points. I didn't know if you actually knew that went back to the original, or if you just didn't do the problem. Next one up, 90. What are some factors in 90? 30 and 3. So 30 and 3. Factors of 30? 10 and 3. Factors of 10? 25. Okay, things that have buddies? 3 come out. What doesn't have a buddy stays locked up, which is? 10. Yep, 2 and 5, so 10. Our next one, we have to multiply our coefficients. 5 times 2, which is? 10. And then if you guys have a calculator, you can do this, but we don't really have to write it out. 14 times 7, whatever it's going to multiply, the first factors we can find can go back to 14 and 7. So I don't really have to multiply that out. What are the factors of 14? 7 and 2, yep. We know 7 comes out. We end up with 10 times 7. Square root of what doesn't have a buddy is 2. What's 10 times 7? 70 square root of 2. Nice job. And then our one after this, we have 4 times 1, which is 4. And again, you don't have to multiply the 12 and the 15 together. Actually, you can just leave it with a multiplication sign because you know your first 2 factors of your factor tree could be 12 and 15. Factors of 12. 6 and 2. Factors of 6. 3 and 2. Factors of 15. 3 and 5. Things that have buddies are my 2s and my 3s. So we have 4 times 2 times 3 square root of what doesn't have a buddy? 5. So 2 times 4 is going to be 8. 8 times 3 is? 24 square root of 5. Nice job, guys. 4590 triangle.
Is it a hypotenuse?
There's something about the hypotenuse. You're correct. But what is it? The legs are the same. And what about the hypotenuse? A root 2. So in this one, your leg is the same. That's A root 2. It only asks you guys to find your x value, but we're going to solve the whole triangle. So on your first one, which side do you have? A, or A root 2? We just have the side length of A, yep. So that means we know over here this also has to be A, so this has to be 6. But your hypotenuse is going to be A root 2, which is 6 square root of 2. After that one, we have another side length. So is that going to be A or A root 2? So since it's not going to be the hypotenuse, it's just going to be a leg. So we know it's just going to be A. It's across from that 40. So down here, that means this leg also has to be 10. And that means our hypotenuse is going to be 10 square root of 2 because it's A root 2. So as long as it's not the hypotenuse in the 45, 45, 90, the two leg lengths are going to be the exact same. And then our last one on this row is going to be the 5 square root of 2. Which side is that? Leg or hypotenuse? I heard you say it. It's the hypotenuse. A square root of 2. We want to get A by itself. You can sometimes see this. You guys can guess what that A is going to be, but if you didn't, you can mathematically solve it. A has to be 5. Yep. So you know both legs are going to be 5. Okay, we have 15 here. What is the formula for the 15 side of our triangle? A square root of 2. Okay, so we're going to divide by the square root of 2. These cancel. We get A equals 15 square root of 2. We have to rationalize. That's why we multiply top and bottom by the square root of 2. You have 15 square root of 2 over the square root of 4. What's the square root of 4? 2. How many times does 2 go into 15? 7.5. Yep, 7.5. So 7.5 square root of 2 are going to be our two side lengths, our legs. Ooh, that's not a 5. Our next one up, we have 2. I would like you guys to look, well, as you've gone through this, I wanted to know if you guys saw a trend. So 45, 45, 90s, you know if you have a leg, whatever your leg was, you attach a square root of 2, that's how you get the hypotenuse. But if your whole number is your hypotenuse, right? What do we notice the connection is between the leg? So here, it's going to be that 7.5. So every time you do it, it's half of your hypotenuse with a square root of 2. So every time your hypotenuse is a whole number, your legs are going to be half of the hypotenuse with a square root of 2. So here, what's half of the hypotenuse? 1. We attach a square root of 2. So that means our leg lengths are going to have to be just the square root of 2, or 1 square root of 2. So I'm going to show it mathematically, but we know what it's going to turn out to be. We know it's going to end up being square root of 2. So we can do that by 2 equals A square root of 2. We're going to divide by the square root of 2. A equals 2 divided by the square root of 2. We have to rationalize. Square root of 2 over square root of 2. You get 2 square root of 2 over the square root of 4. What's the square root of 4? 2. The 2's go away. You're left with just the square root of 2. So again, if your hypotenuse in a 45, 45, 90 is a whole number, to find the legs, you just divide it by 2 and attach the square root of 2. Our next one up, we have a square root of 2, so it's not a whole number. What is our x going to have to be? It's going to have to be 3, yep. Because it's a square root of 2. We divide by that square root of 2. If you don't see it, you can do the math to support it. A equals 3. A equals 3. Okay, so now we're on to 30, 60, 90. What's the side length across from the 30? A, yep. What's the one across from the 60? A root 3. And then our hypotenuse is 2A. So you go over here. Which side length do we have? It's across from the 30, the 60, or the 90? 30. So that means that across from the 30's formula is just A. So that means that 4 is A. So to find the side across from the 60, that's going to be A square root of 3. So that's going to have to be 4 square root of 3. All we did was substitute in the A. To find my hypotenuse, it's going to be 2 times A. What will that have to be? What's 2 times 4? 8. On our second one up, we have 21. Which side is that? Is that across from the 30, the 60, or the 90? It's across from the 30, so that means that has to be my A. Which means the side across from the 60 is going to be A square root of 3. So that's going to be 21 square root of 3. What's my hypotenuse? 2A, which is now going to have to be 42. Our third one here, which side length do we have? The one across from the 30, the 60, or the 90? The 60. So this is the first one that's a little different. So we have to use our formula for the 60 side. What is it? A square root of 3. We got to get a by itself, so we're going to divide by the square root of 3. I get a equals 2 divided by the square root of 3. Can I leave it like that? Nope. What do I got to do? You got to rationalize. Yep, square root of 3 over the square root of 3. Multiply them together. You get 2 square root of 3 over the square root of 9. What's the square root of 9? Does 3 go into 2? No. So a equals 2 square root of 3 over 3. So we know that's going to be this side length right here. Nope, let's try it again, Jenkins. 2 square root of 3 over 3. It's going to be this side length. What's my hypotenuse have to be? 2 times a, which is 4. Yep. Square root of 3 over 3. Okay, which side length do you have here? The one across from the 30, the 60, or the 90? 90. What's our formula for that side? 2a. So if we want to find our a value, we're going to divide by 2. So a equals what? So you can leave it as 3 over 2 or 1.5. So we know the side across from the 30 is just a. So that's going to have to be 1.5. What's my formula for the side across from the 60? A root 3. So that means it's going to have to be 1.5 square root of 3. You could have left it as 3 over 2. That's fine as well. Which one do we have here across from the 30, the 60, or the 90? 30. So that's back to us just having an a. So to find the side across from the 60, we have that a square root of 3. So it's going to be 2 square root of 3. And my hypotenuse is going to be 2 times a, which is 4. Yep. Last one. Which side do we have? The side across from the 30, the 60, or the 90? Across from the 60, yep. So 15 equals, what's my formula for the side across from the 60? A square root of 3. So this is going to be one like the one we just talked about. It's kind of ugly. Divide each side by the square root of 3. You end up with a equals 15 divided by the square root of 3. What do we have to do next? Rationalize. Square root of 3 over the square root of 3. We end up with 15 square root of 3 over the square root of 9. Well, how many times what's the square root of 9? Just 3 going to 15? Yep, 5 times. 5 square root of 3. You see that it has that square root of 3 attached to it? That's the only way that would make the other side, when you multiply it by the square root of 3, a whole number. So you knew that a had to be that way. What's our hypotenuse going to be? 2a, so it's going to be 10 square root of 3. Exactly right. So this is where I had you guys have that new phrase. What's our phrase? Some old hippie came a-hopping through our apartment. Again, this is something I would commit to memory. If not, tomorrow's going to be hard. So looking at 42, we need a trig function that's going to reflect the two side lengths that relate to 42. So which ones are they? So we have which sides? Opposite and adjacent. Which trig function does opposite and adjacent? Tangent. Yep. So tan of 42 equals opposite of 42 is? Adjacent to 42 is? X. Remember, this is where we do our cross multiply and solve. So we put tangent over 1. We end up with 7 equals x times tangent of 42. We're going to divide by tangent to get that x by itself. So tan of 42. These go away. I'm left with just x equals 7 divided by tangent of 42. So I'm going to make this note up here. I told it to you guys a couple times, but in my last class I had people ask still. We only use inverses to find angles. So if we're given an angle, we're not going to use an inverse. So here we're given an angle, so we're just using regular tangent. So here, when you put in your calculator, you have 7 divided by tangent of 42. What do you get? 7.8. Thank you. Our next one up, we're given an angle again. That angle's 82. What side lengths do we have in reference to 82? Opposite and hypotenuse. Which trig function's opposite and hypotenuse? Yep, so sine of 82 equals opposite 8 over hypotenuse x. We're going to put sine over 1 again so we can cross multiply. X sine of 82 equals 8. We want to get x by itself. What do I have to do? By sine of 82. X equals 8 sine of 82. You're going to put in your calculator as is. 8 divided by sine of 82. 8.1. Next up, we have 63. Which trig function do we have in reference to 63? Adjacent hypotenuse, perfect, which is? Yep, cosine. So adjacent is 9. Hypotenuse is x. One more time, we're going to put it over 1. We're going to cross multiply. X cosine of 63 equals 9. If I want to get x by itself, what do I have to do? Divide by? Exactly right. Divide by cosine of 63. So 9 divided by cosine of 63, which is? You said 19 point what? 8. Thank you, ma'am. Okay, which angle do we have here? We have 26. So which trig function do we have? So the sides are what? Opposite and adjacent, so that means it has to be tangent. Yep. So tan of 26 equals opposite over adjacent. One more time, put it over 1. Cross multiply and solve. So we have 7 equals x tan of 26. Want to get x by itself, what do I have to do? Divide, yep, by tan of 26. These go away. X equals 7 divided by tangent of 26. 14.4. X equals 14.4. Thank you. I'll change my color so we can see what's going on in my next problem since I have so much there. So our next one, we have 77. Which sides do we have in reference to angle 77? Yep, opposite and hypotenuse. Which trig function's opposite and hypotenuse? Sine. Yep, so sine of 77 equals opposite 8 over hypotenuse x. Put it over that 1. We're going to cross multiply. So x sine of 77 equals 8. Same steps as the last 4. Divide by sine of 77. We end up with x equals 8 divided by sine of 77. What is 8 divided by sine of 77? Can you say it one more time? 8.2. Thank you. Okay, I'm going to give you a second to catch up. So we have the angle of 51. Which sides do we have in reference to 51? We have the adjacent right next to and the hypotenuse. Which trig function's adjacent and hypotenuse? Cosine. Thank you. So cosine of 51 equals adjacent over hypotenuse, 9 over x. We're going to put a 1 in the denominator, cross multiply. X cosine of 51 equals 9. When I get x by itself, I'm going to divide by cosine of 51. X equals 9 divided by cosine of 51, which is 13.3. 14.3. Thanks. So here we're searching for the angle, which means we have to use what? We're searching for angles. What do we have to use? The inverse. So because these are all angles, we know we're going to have to use inverses. So we want to know which side or what angle we're looking for. We're looking for angle x. Which sides do we have in reference to angle x? And adjacent. So which trig function does opposite and adjacent? Yep, so we have tangent of x equals opposite over adjacent. Now to get that angle measure, x, we have to apply the tan inverse. So tan inverse of 7 over 12. Can you say it a little louder? 30.3? 30.3 degrees. Our next one up, we have another x that we have as an angle measure. Which sides do we have in reference to x? 12 and 8. The 12 and 8, which are the opposite and the hypotenuse. Which trig function is opposite and hypotenuse? Yep, it's going to be sine. So to find x, we do x equals sine inverse of 8 over 12. What is sine inverse of 8 over 12? 41 point what? 8 degrees. And last but not least, we have another angle x to find. Which sides do we have? Yep, adjacent and hypotenuse. Which one was adjacent over hypotenuse? Yep, so cosine of x equals 14 over, or 7 over 14. So cosine inverse of, you can write just 1/2 if you want, or 7 over 14 equals 60 degrees. Okay, so there's one other thing I want us to do real quick. I know we're done, but I want to make sure you see it before we go on. So you can write it on the back page or whatever. I'm going to make sure everybody gets this down, and then we're going to go do that real quick. So if we had just a generic triangle, and we had to write out the ratios to find this, and we had our sides as t, our angles as t, d, and y, what would be sine of t? So sine is what? Opposite over hypotenuse. So what's opposite of t? dy. So remember we named sides, yep, with 2 letters. dy over my hypotenuse of? Yep, ty. If you want to do cosine of t, cosine is adjacent over hypotenuse. Some old hippie came a-hopping. So what's adjacent to t? td over my hypotenuse of? ty. And then last but not least, we have angle, our tangent of t. Tangent is through our apartment, opposite over adjacent. What's opposite of t? dy over td. Thanks, guys. Okay, so I just want to make sure you guys see this. There'll be a question similar to this in the quiz.